Good day, friends and viewers. Welcome to this lecture on paper chromatography. Paper chromatography is a method for analyzing and purifying compounds from plant extracts, amino acids, proteins, peptides, alkaloids, and inorganic cations. It is the oldest chromatography process and is used to separate complex mixtures of polar and nonpolar compounds. It was discovered in 1943 by Martin and Senge. Don't forget to like, comment, and share this video. Objective of the lesson. By the end of this lesson, students are expected to be able to define chromatography, apply the theory of paper chromatography, calculate the retention factor, and explain the factors that affect the retention factor. What is chromatography? Chromatography is a laboratory technique for the separation of a mixture into its components. The theory of chromatography is based on the principles of differential partitioning of substances between two phases, a stationary phase and a mobile phase. What are the key concepts of chromatography? We have 1. Partitioning, the distribution of a substance between two phases where the substance is more soluble in one phase. We have stationary phase, that is the phase that remains fixed in place, such as a solid or a liquid coated on a solid support. We have the mobile phase, the phase that moves through the stationary phase, such as a gas or a liquid. And then we have distribution coefficient, a measure of the partitioning of a substance between the two phases. We have different types of chromatography, but we will be treating paper chromatography, used to separate different dyes, pigments, amino acids, etc. What are the steps for paper chromatography preparation? One of the steps, or the first step, is to draw a line with a pencil 2 cm below and 2 cm above. The line below is what we call the baseline, while the one you have drawn above is what we call the solvent front. The second step is to add a sample of dye or whatever pigment you want to separate on the paper. And then third step is you add solvent front in the tank or beaker. Make sure that as you add a solvent front, the paper you add inside will not be covered. Just as you're seeing in that figure 1, the solvent front is below the baseline. You place the paper and see the top of the paper. You cover that paper so that the solvent will not evaporate. And the fifth step, you watch the different components separate. They will separate. The components in that dye or in that pigment will separate. For this one, we are seeing two components were separated, one at 4 cm and the other one at 8 cm. Step 6, you remove it from the tank when it has reached your solvent front. That upper 2 cm you mark. The moment it reaches that place, you remove the paper from the tank and you allow it to dry. As you allow it to dry, you will be able to see the spots, or if you don't see it, you can use developers to identify your chromatogram. Why do different molecules move in different rates? Movement is affected by mobile phase and stationary phase. A mobile phase is a substance that a molecule can move in. It can be a liquid or a gas. In paper chromatography, it is the solvent that we used in developing our chromatogram. A stationary phase is the phase that remains fixed in place while the mobile phase moves through it. The stationary phase is usually a porous solid like glass, silica, or aluminum that is packed into a tube or makes up the walls of a capillary. For paper chromatography, it is the paper. In chromatography, the substances are changing between the two phases, the mobile and the stationary. 1, they are dissolving in the solvent before moving. and 2, they are bonding to the paper before moving. Note, they spend the time in the two phases. How fast they move depends on the time they spend in the two phases. The chemicals that are soluble in the solvent will spend more time in the mobile phase and so will move faster. The chemicals that are not soluble in the mobile phase will spend more time with the stationary phase and will move slowly. In the figure shown, the blue substance is more attracted to the stationary phase, so it moves slowly, while the red substance is more attracted to the mobile phase, so it moves faster. We said that the movement of the molecule depends on the substance used. We are expected to calculate what we call the RF value or the retention value, which is the distance moved by the substance divided by the distance moved by the solvent. This is the way you keep your chromatographic result. You write the name of your extract, like in this table 1, we'll have amino acid, the color of the spot, the distance moved by the spot from the original line. It said it's 9.9 cm. And then the distance traveled by the solvent from the original line, 12.7 cm. Then calculate the RF value. The RF value is the distance moved by the substance divided by the distance moved by the solvent, which gave us 0.78. The second one follows the same methods. RF values are usually expressed as a fraction of 2 decimal places. If RF value of a solution is 0, the solute remains in the stationary phase and therefore it is immobile, it didn't move. But if RF value is 1, then the solute has no affinity for the stationary phase and travels with the solvent front. RF value does not have a unit because the centimeter and centimeter usually cancel out. If a compound is colored, it can be easily located on the chromatographic paper. If the substance is colorless, however, we have reagents that we can use to develop our paper. We can use iodine, and we can also use anhydrine to develop the paper, and then we'll be able to identify the spots. What are the factors that affect RF values? The nature of the solvent, 1. The composition of the solvent can affect the interaction between cellulose and the substance, influencing the RF value. More polar substances tend to interact more strongly with cellulose, leading to higher RF value. Cellulose can form hydrogen bond with the substance, which slows down its migration and increases the RF value. Nature of the substance. Cellulose can absorb the substance, which can affect the migration and RF value. Temperature. Increased temperature increases the kinetic energy of the molecule, so result in faster migration, increased RF value, and reduced separation. We also know that reduced temperature reduces kinetic energy, causing slower migration rates, decreased RF value, and improves separation between substances. The optimal temperature for paper chromatography is between 20 degrees to 30 degrees. Molecular weight can also affect RF values. Larger molecules tend to interact more strongly with cellulose, leading to higher RF values. Presence of impurities and quality of the paper can all affect RF values. Solvent composition. The composition of the solvent can affect the interaction between molecules, between cellulose and the substance, influencing the RF value. Water is good for separating polar substances, amino acids, and sugar. Water ethanol mixture of 1:1 or water acetic acid 1:1. Ethanol is polar, used in combination with water, can separate alkaloids and glucosides. Ethanol with chloroform 1:1 or methanol chloroform 1:1 ratio. Chloroform is non-polar. It's good for the separation of lipids and sterols. A chloroform mixture with methanol 2:1, or hexane and ethanol 1:1. Acetic acid is polar, used in combination with water and ethanol. Amino acids and peptides. They are good for those separation of amino acids and peptides. Butanol is non-polar. It is used to separate lipids and waxes. Applications of paper chromatography. Paper chromatography is important for checking the purity of pharmaceuticals, detecting adulterants, detecting contaminants in food and drink, detecting drugs and dopes in animals and humans, analyzing mixtures in biolabs for forensic scientists to identify DNA prints. We can use paper chromatography. Very good for reaction monitoring, but it has its limitation. It can't handle large amounts of sample. It's ineffective in quantitative analysis. It can't separate complex mixtures, and it's less accurate than high-performance liquid chromatography. Study questions. 1. The following distance of spot were obtained from a dye solution on a paper chromatogram: 2 cm, 4 cm, 8 cm, and 12 cm. From the values obtained, calculate the retention factor for the various spots with the solvent front as 12 cm. 2. Explain what affected the 2 cm and 12 cm values. 3. Give 5 applications of paper chromatography. Thank you. We have come to the end of this lesson. Don't forget to subscribe, like, comment, and share. Thank you.